Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, and it is time for another episode of Let's Make It. It is Monday night at 9 p.m. where you can come and join us live and chat in the chat room. If you're not in there, you should make sure you come at 9 p.m. Eastern Time and chat with us on Monday nights. Speaking of 9 p.m. on Eastern Time, we started asking last week, what's the best time for you to come watch live? Maybe we're not doing it the best time for you. And I've got a couple responses back, but not as many as I would like. So go ahead and send an email to letsmakeit@tech-zen.tv and let us know what is the best time for you to come and join us live. It's always okay, definitely, to download from either YouTube or from iTunes or wherever you get your podcast to get our show. But we'd love to have you in here. And if we could make some adjustments and you come join us, we definitely would appreciate that. But it is Monday night and it's just 9 p.m. And we are going to do episode number 32 of Let's Make It. Now, I am kind of Bob-less tonight. I'm not sure if me getting back from vacation, officially today was my first day back. I haven't really had a chance to talk with Bob. I thought he was going to be here with me tonight, but maybe he had some other kind of conflict. So I'll make sure I get with him a little later tonight and make sure everything's okay on his side. But he has not called in yet. And if he calls in during the show, we'll definitely get him connected. But right now, he is not online, so I can't connect him up. But we still have a nice full show tonight. We are going to start using one of the new shields. In fact, today I got in the mail 3 more shields, and I still got more coming that we're going to start selling. But I took one of them that I showed you a week or two ago, and we're going to use it tonight in tonight's show, and it will give you all details. Now, if you hear that little noise back there, that's actually the Skype machine in the background. Let me go ahead and kind of mute that, not mute it, but bring it down so it's not bothering everybody, just in case Bob joins in. All right, so the other thing I want to mention is, I mentioned this last week just to make sure, we have now set up a Google Plus community. If you go to tech-zen.tv and click on the community link at the very top, it'll take you to the community where you can communicate and chat with other people that are watching any of our shows. Let's Make It just being one of them. But if you have an Arduino question, maybe you can get some other people's perspective or other suggestions. Bob and I are, well, I'm definitely out there looking at it. It's very empty at the moment, but we're trying to get that built up. And I think Bob's been out there too. I haven't asked him recently. When I send him an email tonight, I'll make sure that he's out there checking it out. So just another way of communicating in more of a community, because what's happening right now is we get questions and we answer them, but we're answering them to one person, where if they could be asked and help other people, we would much rather be able to help out other people with answers to the questions. Okay, so let's see. One last thing before we get started, we had the Alexa TV. I mentioned last week, you'll see at the beginning of this week for sure, the Alexa.tv intro. And that doesn't mean anything's changing with TechZen. It's just another network. It's a sister network, basically, to TechZen. It's just going to do things that are non-technical as well as technical. So our TechZen shows will be there as well as other non-technical shows. But we started that definitely started this week. I thought it was going to be last week for Let's Make It, but it's this week. I saw it earlier. All right, and I am officially back from vacation, so things will start to turn back into normal times for us. And I have no plans for any other vacations this year. Well, no plans yet. That may change. But what I want to show you, I have a thing here, and I'm going to show you this, and I'm going to leave it on the screen while I talk a little bit about it. So this is kind of a what is it type question. Can you guess what this is? And when I got this, it was not what I expected. I will say that for sure. You can see that they are paper-wrapped capacitors. That big yellow one is a 22 microfarad. I don't know how many watts it is. It's not that much, though. The ones, basically what I'm doing is I'm going to replace these old paper-wrapped capacitors with newer metal capacitors, which are much, much smaller. So I am actually doing this for my wife's uncle. Well, I guess an uncle-in-law to me. But have you guessed what this is yet? You're probably not going to be able to guess it. Actually, if I showed you a watch, you probably still wouldn't guess it unless you collect what this belongs into. So this actually came out of a 1940s jukebox. I believe it's a Wurlitzer jukebox, if I remember correctly. And my uncle-in-law, or my wife's uncle, however you want to put it, collects jukeboxes. And when you get these old jukeboxes, you typically need to change the capacitors because the paper wrap ones don't last very long. Definitely not the 73 years since it's been made. So he basically bought a kit of capacitors. So I'm going to take out these old ones and put in the new ones. Well, when he asked me to do it, I originally thought I was going to get some kind of PC board, which makes it very easy to change out capacitors. But these are all parts soldered together. I have never quite seen anything like this before. But I thought it was interesting enough that I would bring it on the show and show you. Now, this thing is probably 20 to 24 inches long. You're seeing it, let's see, are you seeing it? You're probably seeing 7 inches of it, maybe 8 inches of it. You're about one, probably closer to a foot of it. So it's almost twice as big as what you're seeing there. But all of the capacitors and everything are in that one area for the most part. Actually, if I slide it down this way a little bit, you can see down at the bottom, there's a few more resistors and things kind of crowded together. But it does take tubes. Tubes go on the other side. This is the underside of the amplifier. So something I'd never seen before. I was not expecting. I expected old capacitors, but I really expected this to be on a PC board. I wasn't expecting parts to be soldered to parts to make a run. So this is going to be a bit of a challenge, although I think it's going to be a very fun challenge. But I just got to take my time and make sure that I do one at a time and complete all the connections as they were before. So it'd be a lot of testing, going back and forth, making sure everything is working. Like I said, this was out of a 1940s jukebox. I think the mechanism he sent off already, he had some problem with the mechanism in the jukebox, and he sent that off to get repaired. And I think this still works. It just doesn't sound real good. I don't know what happens to capacitors, the paper wrap ones, necessarily how they degrade, but with technology, I'm sure we've made that much better. All right, so let's get on with the show. So this week, I mentioned about showing you one of the shields we've had made. And this is a little bit of a weird one. I saw somebody talking about it and different ways of doing this. And actually, I've created a couple of different sketches on how this is works. So we can take we're going to take different parts of it, because we've done some things in the past with different kinds of things, but we never really just explained in great detail how they work. So that's kind of what I want to do tonight as well. So before I do that, let me go ahead, and I'm going to put down this amplifier onto the floor. Hang on one second for me. It is very heavy, by the way. It's probably 25 pounds maybe. Alrighty. That's down there now. So let's go ahead and let's show you what we're going to be working with here. Let me get this over here where the camera is at and go back to the camera. So it doesn't look like much, does it? What this is very few parts really. And I'm going to show you the schematic. It's very easily to do on a breadboard. We do have shields you can buy, and we can get all the parts from us now as well. Although the store's having some issues, but we're still almost there. We're in fact, I took pictures of things tonight. I'm still taking pictures for the website now, so we're that close to that. We're actually putting pictures up now and of all the different pieces and stuff. So that should be available hopefully by next week's show. But what this is essentially a biofeedback sensor, and we're going to use it to be a lie detector. So that's how we're going to use it. I'm going to walk through some different parts to it. But basically, the 3 resistors right here are just for this LED. It's a RGB LED, which you can barely see because it's white. It's one bad thing about using whiteboards. And then there is a speaker jack here, which I put jumpers on. But we have the buzzers that go into those holes. 2 sensors, which are right there, 1 for each finger, and then an adjustment knob. And then this resistor basically just pulls this to ground. Is it ground or 5 volts? I can't remember now. It pulls it to 5 volts, basically, so it has something consistent on it. But we'll walk through the schematic, and I'm going to show you different sketches we're going to do with this to show some different features of it. But first, let's go look at the schematic. Let me get that up here. All right, let's go over to the computer. And I will zoom out slightly and get rid of this side. This is in Fritzing, which we've showed you before. It's a very simple schematic. Basically, you have the Arduino, you have your RGB LED, you have your buzzer right here, and here's the potentiometer, and then here is that resistor, and then these are the two pins where you put your fingers. So what happens is the pot, and I'm going to walk through this and show you this, the pot adjusts basically the value. So what you do is you take your friend you want to put on a lie detector, and you put their fingers on it, and you adjust the pot until it turns green. And then you start questioning them. Put the bright lights on them, whatever you're going to do. And it'll either turn, if it turns blue or red, you need to have caution. Technically, red is the way it's supposed to go, but after reading some other people's things, your resistance in your body changes. It can go either direction, but typically it goes down when you're lying. And I don't know if it's perspiration that does it or what it is that does it. I never saw a really good description of it. But if this value changes very far, you change the color of the LED, and you can activate a buzzer. I don't have a buzzer in mine because I didn't want to sit here and be buzzing through the microphone and annoying her, but that's why I just put pins on it. But our kit does have a buzzer on it. And I think there's actually enough pins that come with it. You can put the pins in there and put the buzzer if you want, because we generally send a 36-pin strip, and you only need 32 for the Arduino, and there's four pins in use. So you would have enough pins to put that. If you didn't want to use the buzzer directly, you could just stick those headers in there. So that is very, very easy, our very quick overview of the schematic. So let's go, and I'm going to run a couple of programs that I want to show you here as well. Let me go get that all set up for you. And let's see. Arduino. All right, the first thing I'm going to do is I'm going to show you the RGB LED. We've never really talked about the RGB LED, and I mean, it is what it is. It's a red, green, and blue LED, but it allows you to control each color individually. It basically has 4 pins on it. Now, you've seen us use this before, but we've never really explained what it was, and I don't like, after I thought about it, I didn't want to assume you knew what the RGB LED did. So I'm going to very quickly walk through some code. I'm actually going to make some changes to it to show you a couple different things as well. So let me go ahead and plug in the Arduino. Get the cable here. Okay, the Arduino is plugged in, and it is running a program already. It's running. I'm going to go to that right now. You'll see the LED is changing colors. Can you see it changing colors on the screen? Well, slightly. You see it's blinking. It's changing colors. I probably should have made that a little bit brighter, maybe. The LED a little bit brighter. You can tell from the side. No. Add examples. All right. What you can't tell is it's changing colors. It's going through every color that it can do, and it's going to take it a couple of minutes to go through all the different colors. It's very blue at the moment, but there's some red in it, and there's some green in it, and it's cycling through all the different possible colors. So let me do this. Let me just go to the program, and let me show you what it's doing. So this is the color rotator. And the way I've done the colors in here, because I'm using pulse width modulation to turn each color on at a different brightness, here's how I'm doing that. So first of all, I'm defining the pins, and this shield has red pin on number 9, green pin on number 11, and blue pin on number 10. So I come down and I set up the pin modes, obviously, and it's ignore these colors for the moment. And then I'm coming down here, and I'm basically increasing the current color value by increasing it by 100. So you notice this is a long integer, so it's the big integer. It's a 32-bit integer, and so let's go back up top here slightly, and you see right here I'm defining red as being the top 16 bits as on, and then the bottom the top 8 bits is on, the bottom 16 bits are off. Is that right? No, I was right the first time. Anyways, the top part is FF0000 is red, and this is just like RGB. If you're doing any color space, this is what the RGB colors are like, even on the computer. So that's kind of why I did it this way. If you go into any of your graphic software and you set it up for FF0000 for the color, you're going to get pure red. And if you say you want your color to be 00FF00, you're going to get pure green. And if you want your color to be pure blue, it's 0000FF. I didn't like the color blue with FF, so I made it 80 in my case. So, but basically what this loop is doing, this loop is going through and it's starting at 000000 and incrementing it by, what did I say? It was incrementing it by 100 each time. So instead of just saying I want red, green, or blue, it's going through every color possibility in increments of 100. So that's what it's doing. You just can't see it real good on the camera. So I'm going to do something a little different here. I'm actually going to change the color of it to red. And let me re-upload this. Let me make sure I got everything set. I do not. Good, I checked. All right, I'm going to upload it. And you can really see it looks pink to you, but it looks red to me. So it just happens to be the white board. So what I'm going to do is I'm going to change that to green now. So let's do this. I'm going to go green. And upload. And there you can see it's green. And I can do blue, but we already know blue is very hard to see. There's blue. It looks kind of purplish. Let me make blue a little darker and see if it's happier with that on a camera. Let's see. Not much to you. It looks darker to me, but not much to you. All right. So anyways, what I did there was I just hard coded this color blue in here. So there's one thing I haven't talked about yet, and that is this set color function. So what you could do if you didn't want to adjust the color of each color, like the value of each color, you could just say that red pin is on, or its output is true, or it's green as output is true, or blue as output is true. The way I've done this, though, you can color mix any color in the spectrum by using any of the RGB values. So here's how we do that. Set color basically says that red is equal to the first 16 bits, or the first 8 bits, and that means it's a 24-bit color. Sorry, I told you 32 before. It's 24. That's why I couldn't end up in my head. Anyway, so basically to get around that is you just shift the RGB value to the right 16 times, which that puts the top 8 bits as the bottom 8 bits. So we never talked about shifting before. So basically, if I shift this value over 16, anything that is 15 or below, it gets pushed out. It's basically gone. So the top 16 bits are now the bottom 16 bits. I'm sorry, the top 8 bits are now the bottom 8 bits. We're talking about an integer, so we're talking about 8 bits. All right, so in green, I want to shift it right one time because it goes red, green, blue. So red's the high 8, green is the middle 8. So I shift it to the right 8 times. Now I have to do this ampersand, so I'm basically doing an AND operation, and this says I only want to take the bottom 8 bits, because if I didn't, I would get the red. It would be in the same position of where green was. So this is how I keep it only the bottom side. And then I can say I can do the same AND condition where with RGB, saying I want to ignore anything above the bottom 8 bits. So I'm only going to get back the 8 bits. So blue is the rightmost 8 bits. So I can just say I want the rightmost 8 bits. So that sets these variables, and then I come down here and I set the variables to the pins, and that just changes the color. So I can pick any color in the color spectrum that you can make with our red, green, or blue. It's basically what ends up happening doing it this way. Instead of doing a full blue, full red, or full green, or any combination of those full colors, I can make any color in that spectrum. So the reason I wanted to show this to you is that this is a function that I'm doing in the actual routine that does the lie detector. So and I'm going to go through another thing here. It shows how we read the lie detector and basically the biofeedback. So let's do this. Let me get back to the other program. So that's killer. And we're going to do feedback. All right, let's go back over to feedback. And let me scroll down here slightly. All right, so our potentiometer is on pin number 1, and our sensor is on pin 0, which is these are the analog pins. And then we have this band, and what band is like an adjustment. So what I had to do is I had to play with it slightly with the potentiometer. I kind of put it in the middle, and then I figured out what value I was generating, and I'm going to show you this as it runs, versus what value the potentiometer was in the middle, and then I adjusted the band to be equal so I could go both down and up for different people, so it was adjusting. But I'm going to walk through how to adjust it for each person as well. So what we do here is we set pin modes to input for both the potentiometer and the sensor. And in this particular sketch, I'm actually going to output this to the serial port so we can show you what we're getting. And then we'll put this all together and make an actual lie detector. I can't test it because I can't lie to myself. So you have to need somebody else to test it with you. All right, so here's what we do every time we go through this loop. We are going to read the sensor. We are going to read the potentiometer, and then I'm going to put those values out to the serial port, and then I'm going to actually do the compare that I want to do in the real lie detector. So, but rather than turning on LED, I'm just going to print to the screen either red, blue, or green. And the way that works is if the sensor value is greater than the potentiometer value plus the band value, then it's red. That means your resistance has gone down. And if it's the other way, it's blue. And if it's right there where it was when you adjusted it, then it comes out green. And then I delay half a second and we go back and we do that again. And that's just so we don't overwhelm the serial port with data. So here's what I'm going to do. I'm going to go ahead and I'm going to upload this. And then I'm going to turn on the serial port. All right. I'm going to go serial monitor. Okay, so you're seeing the potentiometer value is 102. The sensor input is 10, 12, 14, somewhere in that range. It's pretty decent. And blue basically means that the resistance has gone up. All right, so I'm going to go put my fingers on it. And the sensor input you see is, let's make widen the screen a little bit so it doesn't jump back and forth. All right, so you see the sensor, the potentiometer is at 105, 104. I'm at 150 something, 160. I'm bouncing around, considerably. And we know that we have set 50 for our band. So 105, 104 plus 50. So you see I'm getting in that range, but I'm bouncing around a lot. And I don't know why. Maybe it's because I'm talking, because I wasn't doing this to me before. So actually what I'm going to do is, because it's very consistently up, I'm actually going to increase the band value just slightly. I'm going to go up to 55, see if it keeps me in the green. Now you can adjust the potentiometer. You need a very small screwdriver, which I didn't bring in with me. So I'm just going to adjust the band. Let me re-upload this. And let's watch this again. So my fingers are still on it. All right, so now I'm green. So by theory, well, so if I take my fingers off, see it's blue. So blue means if it goes out of value at all, if it goes down like 130, it's going to turn to blue. So that generally means something is wrong. And what I was reading, you can go both directions when you're lying. So okay, so there we are. We're green. My fingers are on it. Now I can't lie and make it go off because I'm not really under stress. So, but it does turn red. It says red if I am lying, supposedly. I don't have anybody to test this, obviously. So basically what you're doing is you're getting biofeedback here. So the sensor input is the biofeedback, and the potentiometer is your adjustment. So you read the potentiometer to make adjustments for that particular person. And in my case, the potentiometer I'm using is a really small one that requires a small screwdriver, which I did bring into the room with me to make that adjustment. But the way it works is you have them put their fingers on it, and you adjust the potentiometer until it turns green, and then you start asking them questions. And if it turns red, they're lying to you. And blue apparently can mean they're lying as well. It's just out of range. It could also mean that you took your fingers off, just like that. So, but this is how the lie detector works. So let's take this biofeedback input that I just did. Now right there, my fingers are on it, and you see it's still bouncing around. It's a lot lower than it was before. So I don't know why that is. There, it's back up. Let me make one suggestion too. Don't put something pointy on, because if you look at this board, you'll see that I actually used headers that I cut down into individual pins in my fingers. I don't know if you can see them, but they have dents in them because of it hurts. It hurts when I put my fingers on it like that. So very, very pointy. So if you can think of something that's not quite as pointy and would work, I would recommend that, because it does hurt. All right, so let's do this. I'm going to go over and I'm actually going to load the code for the actual lie detector. And here we go. Oops. All right, I'm going to load the code. It's loading. I'm not done uploading. Okay, so let's go over to that now. And you see it's bluish right now. I'm going to turn this that way so I can get my fingers on it a little easier. It's bluish, pinkish kind of color. I don't know what that color really would be. But I'm going to go ahead. I would say it's blue. That probably means my fingers aren't on it. So I'm going to put my fingers on it. All right. That's definitely blue. All right. So I have to either adjust potentiometer or adjust the... Oh, you know, in the last sketch, I adjusted the band. So let me do that. Let me put the band up where the other one was, and then it'll probably work for me. All right, we're re-uploading. All right. Must be like right on the edge, because it's blue still. Red. All right, there we go. So I'm green. I'm green now. Let me take his fingers off. It goes blue. There's green again. It takes a little while. And I can't make it go red. Now you can't always see this on screen because I got the white background. I'll have to remember that next time, not to use white PC boards when I order these. See, it's blue right now, so it shouldn't be blue. There it is, it's green. It's like, it depends on where I put my fingers. And the harder I push, the better it seems like it picks up. But let me just say, you can see little dents in my fingers. It definitely hurts. So let's go walk through the sketch real quick. All right, here's the lie detector feedback. So this basically takes what we did in the other two and brings it into one. So here we go, red pin 9, green pin 10, blue pin 11. Actually, this is backwards. That's maybe why it's acting kind of funny for me. Let me fix this and see what it does. Let's go back to it real quick. All right, so blue is low. Doesn't seem to really make much difference. It's not any more sensitive to my fingers now than it was before. All right, so let's go back. Sorry, jumping around. All right, so in this case, I have a buzzer too. So buzzer is pin number 7. Then I have the pot pin and sensor pin. And then I have the colors. And here I define blue again as 80. I like the color better than the dark blue. The band, which I set to 60 in the other sketch. Then we define all of our pins for inputs or outputs, which we have with both of them now. And then we go through something very similar we did before. We have our analog read for both the sensor and for the potentiometer. And here is the condition. If it's greater than, if the sensor is reading greater than the potentiometer plus the band, then it's red. The person is lying. And plus I added a beep routine, which I'm going to walk through here shortly. And if the sensor is less than the pot minus the band, then it means that the person removed their fingers from it. So it's blue. And if it's neither of those, it means their fingers are on and they're not lying, then it is green. And then we have the same set color we had before, right here, same set color. And then we have the beep routine. So all I'm doing on the beep routine is making I think I figured out it's 50 hertz, 50 kilohertz, 50 hertz sound, which is like just slightly below ground hum. But the buzzer doesn't sound like a ground hum. It's very loud and noisy. That's why I did not put it on, because it's very annoying. It's like wah kind of sound. It's just very annoying. All right, so all I'm doing here is I'm just doing this, and I do this for 1,000 times. So it's like a 5 second. I think it's 5 seconds of a delay, because these are microseconds, delay in microseconds. So it ends up being, so it's a 5 second buzzer if they are lying. All right, so that is the lie detector. Very simple biofeedback. You can bring you right into Arduino and get information. In fact, I'm thinking about looking at the biosensor, the biofeedback. I think it's more real life, more realistic than the lie detector, because I think it'll give you a good idea of what you're feeling and you can calm yourself down. So I'll have to try that. I've never did a biofeedback machine before, but I'm going to have to give it a shot and see what it's like. All right. I don't really have a lot tonight. Being my first day back, I will talk to you a little about what next week is. Where do I have it? I have it here somewhere. Here it is. This is next week's Let's Make It. Let me get it over here to the camera, and you can see it. Doesn't look like much. I still have to put the chip in there, but what this is a camera controller. So we're going to build a time-lapse camera controller for next week's show. This allows me to control, from what I have found so far, a Canon or a Nikon camera, and I have the cables yet to make. I use Canon cameras for the most part for everything. So I will get my 5D Mark II in here, and we will give it a shot and see what we can do with it. It has the right plugs and everything, I think, from looking at it, but it's a very basic circuit. It's a timer circuit. This is a relay chip that we use to control. This is a photo sensor, which we can use to determine when it gets getting dark outside. So it doesn't do you much good to have photography in the dark, that type of thing. So we can add all kinds of features in here. Plus, I even added the I2C, so we can add a display, which I'm probably going to add a display for next week, so I can set my options up for the timing and everything. And then I can use these buttons for adjusting up or down or whatever. So I basically made a fairly generic shield that we can use for multiple things, but its original intention was for a camera controller. So that is next week. We're going to set it up and control a camera in time-lapse mode. So one other thing I want to talk about before we go is I got this cool package in the mail, and it is 37 sensors, and here we go, 37 in one box. You can see it's a nice a box like this. So I know I've done episodes on sensors already before, but there's more sensors in here that we never tried before. So we may get some of these out and try to do some cool things with them. Also coming up, rotary encoders. So what do you do in the case where you have rotary input of some kind, but you don't want it to stop? That's called a rotary encoder, and they're very common, more common than you probably think. And after you play with one, you'll see why they're so common, because a potentiometer typically stops at the end, and then if you somehow break the stop, it'll continue on around to the other side, but it'll go back to the low value, or an encoder tells you how many times it's turned, and you just have to keep track of that. And I actually have a project where I'm using an encoder. I'm actually using a lighted encoder even, and I'm trying to build an encoder ring so you can tell where the value is and everything. But I've done a lot with them here recently, and they're very cool. And with the ones that I'm going to demonstrate, actually most of them I think that I have do this. If you push on, it's like an enter button. So we can make all kinds of neat things with rotary encoders. So that's a show coming up as well in the near future. I'm actually running some libraries around rotary encoders now, and I'll be able to give those libraries out. And I got a lot of questions about last week about other I2C things. So, last week we did expanders, we did IO expanders, and you can use I2C to, in that particular case, it was 8 chips by 16. So that's 112 additional IO ports on an Arduino just by using 2 pins on the Arduino I2C. But there's a ton of other things that use I2C. In fact, I'm using 2 different LED drivers that are I2C. One of them I'm using for a rotary encoder where I don't really want to dim. But I found another one that actually allows me to take like an RGB like we showed you tonight, where you can do color changes and do pulse width modulation through the I2C chip, and it's an LED driver as well. It just doesn't have the other one's a lot cheaper for the rotary encoder thing that I'm making, and it doesn't have any of the PWM, but it's like $2 less a chip. So we're going to play with different things like that. There's also a bunch of other things out there that are I2C, and I'm researching a lot of those. So we're going to start talking more about that, and we'll get into SPI too. And eventually I want to do something with like CAN bus or some other type of protocol that will allow Arduino to communicate with Arduino over a little bit larger distance than like an I2C or SPI. And that's coming up as well. And we got a bunch of our shields. We're going to build an oscilloscope. We're going to build an alarm system, a 4-zone alarm system. All that stuff's coming up, and I got a bunch more shields today that I need to assemble and test to make sure they all work before we actually do a show around them, obviously. And that's all coming up in the near future. And we have some other ideas too that Bob and I have been talking about 2 weeks ago on our last show. After the show, we sat down and talked about another project we were talking about doing. And don't want to say we're going to do it yet because it hasn't officially started. I also mentioned the store is coming. It is very close. We have parts in there now. I sent the pictures for everything. So I started taking pictures tonight. And I'm going to continue probably through the weekend, continue to take pictures and try to get all the stuff up there. And at that point, we'll make the store live. It's kind of live now if you know how to get to it. But just come back like next week when we get all the pictures there, and it'll make a lot more sense. I think that might be, well, there's another big project I'm working on. It's not quite ready to show you, but it's going to be coming out, and I'll show you in a real near future. I'm building a prototype of another project, and I'm actually taping as I do it. So it'll be coming out as like a segment in another show, because I taped the surface mounting or the soldering of the surface mount parts using a griddle of all things. I went and bought a griddle because some people do it in an oven. Some people do it by soldering everything on, which I tried, and I'm not talented enough to be able to solder that small of a part. And I like to meet somebody who could. Actually, I've seen people do it, but I never met anybody who could actually do it, because it takes one steady hand to do that. But I did go out and get a griddle, and I can reflow my stuff, and it's actually very cool. I'm going to talk about some of the pitfalls that I ran into, so that if ever you want to do surface mount soldering, you don't run into those pitfalls, because it was very frustrating. But now that I've gotten past them, it's very easy. In fact, when it's done, it looks very, very professional too. It's pretty amazing that you can put the parts on there even kind of crooked. When it gets hot enough to start flowing, all those parts align right up. It's very cool. But I got videotape of that. I got videotape of the project in general. I got different cases now that I'm playing with, although none of them I'm in love with. I'm trying to find a better case, because I'm trying to find, I guess, what they call a keyboard style case, where it's sloped and it looks nice and everything. And I think I finally found one. But I'm still trying to talk with the manufacturer about maybe getting a sample, because they want you to order 500 at a time, and I'm not committing to that yet. So, but those are all things that I'm working on kind of on the side, and I'm taping all this stuff now as we do these projects, because I want to put them on the show, and you can watch the steps we go through when we make things. I think it'd be kind of fun to put that out there. So that's also coming up. Now, a few housekeeping things before they're ready to go. If you're watching us on YouTube, make sure you hit the subscribe button. That's very important for us. It helps us to get found, helps us to do other things. The more subscribers we get, the more things we can do. The same thing goes with iTunes, or anywhere you're downloading the podcast from. We're everywhere, or we'll try to be everywhere at least. If we find somewhere we're not, let us know. We'll make sure we get there. But if you're getting us on iTunes, if you can go out to iTunes and give us a rating, that is so helpful to us. And we're not getting ratings the way we want to get ratings, because we want to get into that new and noteworthy area again, and that requires people to give ratings and stuff like that. So your help with going out there and rating us is definitely appreciated. It helps more than you know. And if you're on Twitter, you can follow us at TechZenTV. And if you are tweeting about the Let's Make It show, make sure you use the hashtag #Let's Make It. And in the very near future, we're going to put a contest around that hashtag as well. We're going to start maybe giving some things away out the store. So if you're on Twitter, make sure you follow us there, and we'll make sure the information is out there as well. If you want to watch us on YouTube, it's youtube.com/TechZenTV. And of course, if you're on Facebook, which it seems like just about everybody is, it is facebook.com/TechZenTV. Go out there and hit the like button, and you can get updates about the show there as well. We also have a great Google Plus community. We're starting to grow it out right now, starting to design it all, but the Google Plus communities are awesome. So we want to get everybody over there. It does require a Gmail account. Don't worry, Gmail's free. If the only thing you use it for is to get the Google Plus community, that's just fine. But yeah, we're going to definitely start doing things over there a lot more. We looked at Yahoo groups, and the Google groups are much more powerful. Can do a lot more with them, and we're going to stick over there. So that's where the community link on our website goes to now. And just a reminder that Alexa TV is still TechZen TV. We're kind of sister companies, or sister networks. Our shows will be on their network as well as some other new shows that are coming around. All right, I think that's it. And I will check on Bob for next week and see if he can make next week. All right, everybody, have a great week, and we'll see you next week. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.